That's the one you want. We're going to be doing logs, change of base, taking the log of both sides. I'm telling you, at least this type of a calculator, and it will make your life a lot easier. I'm going to be doing these actually live. I haven't worked these out yet, so I'll show you exactly the buttons I'm punching to actually get my actual answers. All right, here we go. First off, change of base. This is a very basic formula you need to use if you're evaluating a logarithm that you can't do in your head. Okay, we've been seeing a lot of convenient logarithms. We're starting to get some nasty ones. If I ask you to evaluate this, we're used to seeing, okay, log base 3 of 7 equals x. We put it in an exponential form. 7 equals 3 to the x. Oh no! You don't know a power of 3 that equals 7. So this is where we kind of hit a roadblock until today. Now we can evaluate these using change of base. Now, there's a button on your calculator. It says log on it. It's spelled L-O-G for those of you who don't know how to spell. So, this log base 3 of 7, I'm going to be able to evaluate by taking log 7 and dividing it by log 3. Okay? Now again, the reason I like this calculator is I can do everything with one step. So I'm going to take the log button, log. I'm going to take the log of 7, end parenthesis, very important, end parenthesis, divided by log of 3. Enter. Hopefully there's not too much glare. That's how it's done. And you're finished. Now again, notice I'm using squiggles. Squiggles means approximate because I'm going to round to the nearest 10,000th. Tenths, hundredths, thousandths, 10,000ths, fourth decimal place, but you need to know that already. I get a 1.7712. That is the quick, easy way to take the log of using change of base to find any evaluate log. Okay? Now, part 2 of the lesson is how to solve when it's also, again, we're getting into things that are not convenient. Welcome to life. So, in the past we had this, we would get common bases, right? It was really nice. You'd, everything comes down to 2 to some sort of power. That's gone. These do not have a common base. So what we're going to do is take the log of each side. The same way in Algebra 1 where you wanted to add 2, you had to do it to the other side. We're now going to do that property here. And here's the reason why. Notice where my exponent is. My exponent contains my variable. I don't want there. I want to get my variable out front. Well, we just so happen to have a log property that allows an exponent to come out front when you take the log. So watch what happens. I take the log of both sides, and now I have x times log of 4 equals log of 20. Right? That's using the power property. I'm taking the log of both sides, so now my exponent is allowed to come out front. My recommendation, don't put that in your calculator yet. Don't. Get your variable all alone. It'll make your life a little easier. Well, I want to solve for x, so I'm going to divide both sides by log 4. Now, again, you can take log 20 divided by log 4. Same process. Log 20, end parenthesis. That's very important. End parenthesis. Divided by log 4. End parenthesis. All right. No equals. I'm squiggled because I'm approximate. 2.1610. Careful with how you round that one nearest 10,000th. One more. One more. Woo! Booty nasty. Doesn't change what we do though. Where are my variables? They're in the exponent. I have to get them out front, meaning I'm going to have to take the log of both sides. Same process. Log, log. So now my variables are allowed to come out front. I got a p minus 2 in parentheses, that's the entire exponent, times log of 5, greater than or equal to p log of 2. Okay, this is where I'm going to take a more algebraic approach. Keep in mind, you could take the actual decimal representation of log 5 and log 2 and start solving with fat long decimals. But here's what I'm going to recommend us doing. I'm going to make this p log 5 minus 2 log 5. Everybody say I just distributed the log 5, right? Greater than or equal to p log 2. Going okay? Now, I'm going to do a little switcheroo here. I'm going to bring the p log 2 over here, making it p log 5. To bring it over, I had to subtract it, minus p log 2. I'm going to bring that to the other side by adding it, so now we're greater than or equal to 2 log 5. Okay, so essentially, I subtracted this to bring it over here, I added it to bring it over there. Look at what we have now. I want to solve for p. Do you notice that these both have a p? I'm allowed to GCF it real quick. P times log of 5 minus log of 2. Everybody okay? Right? Pretty basic. Now, look at what I'm going to do here. I'm using properties to help myself out so I don't have to use a calculator yet. We're subtracting two logs with the same base. So I really have p log of 2.5. Right? Because we're subtracting, we can divide. Is greater than or equal to log 25. Right? That number's in front, so it becomes 5 squared. Here's why I'm doing this. I'm about to do my first calculation, and my only one. P is greater than or equal to log 25 over log 2.5. You see how I was able to use all my properties so I only have to do a calculation once, and it's a much more basic calculation. Calculator time and I'm done. Here we go. Same button, log 25, end parenthesis, divided by log 2.5, end parenthesis. Bam. So, P is greater than or equal to 3.5129. That's a tough one. Hopefully, this will help you a little bit on the homework, get a little more confidence in what you're doing. Quick evaluation of using change of base and take the log of each side to solve equations and inequalities. Happy Valentine's Day.